Hello and welcome back to Code Over Time. My name is Kev and today I want to talk about unit testing. More specifically, I want to talk about unit testing in a consistent way across multiple environments, including our continuous delivery pipeline. So let's just jump right into it. We're back on our command line here, and today we're in our Varcade Games website server. So if you've seen previous videos, you will know that this is a Django project. And in our Django project, which is a Python project, we have a number of automated checks that we want to run against our code base. The first is unit tests. Naturally, we want to have unit tests to make sure that our code is correct and behaving the way we're expecting it to behave. We also have type checking. So in Python, even though it's not a strongly typed language, we don't have a compiler, we can do some type checking. So we're going to talk about that. We've also got some code coverage where we can actually test to see how much of our code is covered by the tests, which is both a useful metric and a terrible metric at the same time. So we're going to talk a little bit about that as well. So let's just jump right in. Now, when you're running unit tests, oftentimes you will, from an IDE or from your command line in Python, you might do something like pytest.dot, and that's going to run a suite of tests that you have configured in your local environment. Or maybe you'll run a script or something like that. But to run tests, you need to set up your environment, right? You might need to install, if you do an integration test, you might need to have a database set up. For unit tests, there's various different requirements that you're going to have. I mean, there's the requirements for your project will need to be installed. So you need to do all of this sort of setup. And the problem with that is if I have that set up on my machine and you want to run the tests on your machine, you need to do that same setup. If I want to run these tests on GitHub as part of my continuous delivery, I need to do that setup on GitHub. And there's always a chance that there's going to be a mismatch between environments. And then what happens is our tests don't run. And it's not that the tests are failing because the code is broken. They might be failing because the environment is not set up in a consistent way. So that's something that we're trying to mitigate here. And to do that, we are going to use our old friend Docker. What we're doing is we have a Docker image and we've got some commands here using make, as we've seen before when we're building the project. So if we want to take a look at our make file, actually, let's jump in there. So in our make file, you can see we have some commands here. And again, if you're not familiar with make, don't worry about it too much. Basically, all we're doing is abstracting some Docker commands. So here we've like Docker build, Docker run, but we just need to do build test image, and it will take care of all the various arguments that need to be given to Docker to actually do the work. So we can build a test image, and what we're doing is we're building a Docker image and we're setting up our environment so that we are able to run our tests. And the nice thing about this is by building this image, we are creating an environment that if you build the image on your machine, it's going to be the exact same for you. If I build it on GitHub in our continuous delivery, it's going to be the exact same there. It doesn't matter who's running the tests. They should be consistent everywhere across the board. We then have some commands to actually run the test image. So we can run the image or we can run the image mounted. Now this is important because we can run this image in a way that it just holds the code and it can run the tests. Or we can run it in a way that we take the local code on our machine and we mount that onto the Docker image. And what this allows us to do is on my local machine, I'm going to make changes to the code, and the code is going to be, those changes are going to be immediately reflected on the container, which means I can make changes to the code, I can make changes to the test on my computer, and they're immediately reflected on the image. This is really useful for local development, but if you're running on GitHub or something like that, you want to just run the test image with the code that's on there already. If you're running locally, you want your code to be mounted on the Docker image. We'll go into this a little more later on. Then we can actually run our tests, we can run coverage, and we can run type checking. So let's have a look at what this actually looks like. So first thing you need to do is build our test image. Now I've built this already, so that was super quick. Everything was just cached. And in your case, if you're doing this for the first time, it might take a couple of minutes to actually build that out, but our image is built. So now what we can do is we can do run test image, and we're going to run mounted, right? So now once we run that, we can see we get a little bit of output here that's showing us the container is running, and we can actually check that. If we do docker ps, we can see that our container is up and running. Now if we go to our code, well actually first let's just run our test. So I can use this make run test command, and what that does is go ahead and run our test suite. So you can see we have a bunch of tests all passed, which is great. We have a bunch of warnings. We're not going to worry about them. We just need to do some updates to some of our dependencies. So this is a library that we depend on, and that library is using some old functionality of Django that it shouldn't be using anymore. But down the bottom we can see we've got 10 tests passed, which is good. That's exactly what we want. Now I'm going to go over to my code in our text editor here, And this is one of our tests that I've set up. We don't need to worry too much about the details of the test. It's more the environment and the kind of philosophy behind this that I'm interested in sharing. So if I make a change to the code, so I'm just going to change this assertion here. So I'm going to say if the game is not equal to rock, paper, scissors, which this is going to fail. I know it's going to fail, but this is exactly what we're trying to see. So remember, I updated this code on my local machine. This is a directory on my computer. But as I updated the code, that is immediately reflected. Remember, these tests are running in the container. They're not running on my local machine. And that's what it means to mount a directory. What I'm doing is I'm saying my directory is going to be placed into the container. So it's from the container's perspective, it's running on its local directory, but actually it's my directory mapped into that environment. So we can make changes and we can run our tests here and we can fix this up. Come back to our tests, run again, and we should see that our tests are passing again. So that is basically our workflow for running tests. You know, when you're developing this, what you're going to be doing is you're going to be writing code, you're going to be writing your test code to verify it, you're going to go back and forth to this container and run your tests and make sure everything's going okay. And then when your code is done and you're happy, you'll push it up to GitHub. And then GitHub, we'll go into this in a minute, will build that exact same container. So GitHub is running the exact same environment that you are, and it will have the code in there and it's going to run the tests. And the reason that this is important is that whenever you're setting up an environment with a bunch of, you know, manual steps, there's always the chance that two different environments are going to be different, right? And the more steps you have to execute, the more chance there is that there's going to be differences between your environment. And then you can start getting in failures in your test that has nothing to do with the code or the test, but everything to do with the fact that the environment is set up slightly differently. And there is nothing more annoying and tedious than having a bunch of tests passing and code working on your local machine that when you push up to your repo and your automation pipelines are running, everything just stops working and you're debugging, but you're not debugging the code, you're debugging the fact that the environment is misconfigured in some way. Or maybe your dependencies are, you know, mismatched versions or something like that, right? So that's what we're trying to mitigate here. We are basically running our tests in a Docker image, which is a consistent environment that we can replicate across multiple different places. And it's not just tests, we can also run coverage. Right, so if we do make run coverage, what this is going to do is it's going to run test coverage against our project. So you can see here we've got 95% coverage. We can see our various different files have varying different degrees of coverage. And what this is telling us is the amount of our code that is covered by tests. Now, this is a useful metric just to understand your exposure. You know, it's helpful to know how much of the code base are my tests touching, but don't use this metric as a metric for whether your tests are good or not, right? I could very, very easily write tests to get 100% coverage, but the tests could be terrible. And what they'd be doing is giving me this false sense of security that actually I have these really great tests when I don't. Good testing and a good set of automated tests is not the same as 100% test coverage. They are two different things. Test coverage is just a useful way to see. For example, I might look here and say, right, one of the areas that's really important to me is in my game section here in our services, right? That might be a really important part of the project. And we can see here that it's actually only got 45% covered. So I might be thinking, actually, a lot of my logic is happening here. Maybe this is a place that I should have more coverage because that's where the logic is happening. I don't really care as much about having 100% coverage in my models file. Why? Well, because our models file is actually just a class because it's Django. It's a Django model and Django works. We kind of assume that Django works. So it's useful for kind of pointing us in the direction of maybe we should be doing a bit more testing here. But again, 100% coverage is not a good target because you can write terrible tests but still have 100% coverage. And that leads us to the last thing, which is type checking. So I can do make run type checking, and what this is going to do is going to run our MyPy type checker against our project. Now in Python, as you probably or hopefully know, Python is not a strongly typed language, so you don't have types, but you can hint at types in Python. So we're going to look a little bit at what that looks like. So if I let's say open our game portal, games, services. Okay, so we don't have any type checking going on in here, but what I can do is I can say, I know this product ID is a string, okay? And what that's going to do is tell Python that we expect this, or it's going to tell our type checker that we expect this thing to be a string. So let's look at why that might be useful real quick. So if I say if product ID plus 1 is equal to 10, again, this is like a contrived example. I don't know why you'd ever do that, but let's say I'm doing this and I'm going to just print out all right, because we can infer the product ID is 9 by the fact that our product ID plus 1 is 10, right? Again, this code is useless code. It's nothing code, but we're going to prove a point here. So I can run my type checking and everything goes fine there, but we know, because we are the ones that wrote the code, that this is a string, and saying a string plus 1 equals 10, that doesn't really make sense. Now, if I add a type and run our type checking again, now we're actually getting an error. Now MyPy is telling us unsupported operation for a string and an int. So by including these type hints in our project, what we can do is we can run checks and run this kind of static analysis against our code to figure out, do we have any problems? Have we made any mistakes like this? Which ordinarily you wouldn't catch until runtime, or maybe catch in some unit tests if you have that coverage. So this is just another way to ensure our code is correct. And whenever you're running an interpreted language, I think it's really important to have as many of these sort of checks as possible, because you don't want to be discovering these things at runtime, right? You want to, what we say is push left, right? You want to discover all of these kind of any sort of syntactical or logic areas as soon as possible, not when you're running the game. Last thing to touch on is GitHub. So if you come to your repo, and if you push any code to the repo, you should see that in the action section, we run all of this automation. And if I come in here and I go to VCG server tests, you should see that all of these familiar things are happening here. We're building our test image. We're run tests. So again, it's the same thing that we just saw on my machine in my terminal. We have this run coverage, and it's running all of our coverage here and telling us that. It's running type checking. So as soon as we push up our code, all of these tests are also going to be run and going to tell us if we've made a mistake or if there are any problems with the work that we've done. And that's it. I would encourage you to pull down the project, of course, get the test running locally, run the type checking, make some changes, and just get a sense of how this all works. Hopefully this is useful and makes sense. I think this is something that's generally really important in the software engineering world, is having this sort of automation and automated pipeline in place, but also consistency of environment, so that you're not spending all of your time debugging environment issues, but you're spending your time working on code and fixing tests. Anyway, that's it for this video. Thank you very much for watching. If you want to follow along with Varcade Games and learn what it's like to work on a real world project, please like and subscribe. You can reach out to me if you have any issues. And other than that, have a great day.